Alright, and welcome to Quadratic Regressions. Now everything we're going to learn in this lesson, you already know, so I'm only going to do one example, but we're going to be putting together a lot of difficult concepts. So, really take your time with this one. Anything you don't understand, rewatch, and let's begin. So given the table below, we want to find x when y is 260. Alright, when y is 260. So we can imagine if we created another little row to this table and we just put 260 there, what is our x value? Can we make that prediction? Okay, so let's go ahead and start by what I would encourage you to do with these. Take a photo of it, and then we're going to go on over to Desmos graphing. So step one, take a photo, and then step two, we're going to go to Desmos graphing. Y'all can see here I went to Google, I typed in Desmos graphing, I have graphing calculator Desmos, and here we can begin. Now the first thing we want to do is we want to click this plus, and we want to go down and click table. Now from here we can go ahead and start entering in all of our values. So I have entered in all of our values from the photo that I took that made this very, very easy. And so from here, what are we going to do? Well, we're going to go ahead and we're going to click right below, and this generates another line. Now the first thing we're going to do is we're going to type in our formula for a linear function, which is y1, because notice when you type y and x you have to put y1 and x1 because this is what the table's reading. And then you're going to go shift, and up in the top left corner you put the little tilde, and then mx1 plus b. And guys, every single one of you should know that for a linear function it is this. Now how can you tell if this is the line of best fit? You come over here and you look at this r squared value. Sorry, I can't highlight it. So you look at this r squared value, and you'll notice here, I can do this. You'll notice that r squared is equal to 0.09612. The closer that this number is to 1, the better we have a line of best fit. You'll notice that 0.09, that's almost like saying like 9 cents out of $1. Well, is 9 cents close to $1? No, not at all. So we should know that the linear function is not the line of best fit. So let's go ahead and try a quadratic function. So we'll do y1, shift, the little tilde button, and this is where it's going to be a little tricky for y'all. You have to remember that the standard form of a quadratic is ax1, so we type ax1, and then shift 6, and then we can write squared, ax1 squared, plus bx1 plus c. And now guys, you can see here, look at this r squared value. We have 0.999. Guys, that is as close to 1 as you could possibly get without it really being 1. Alright, and so we should know that we're looking for a quadratic regression. Alright, so here's what I'm going to do. I'm going to go ahead and I'm going to grab this whole thing right here, because I want you to be able to see how do we use something like this. And we're going to go back on over here, and let's paste this. Okay, we can just kind of put that right there. And we now have enough information to write our quadratic regression. So notice we have our formula here. It's kind of in the form of y equals ax squared plus bx plus c. And now we're going to fill in all of these values that we have been given. So I'd say y is equal to, my a value is 4.991. I'm going to go out 3 digits, and that 5 rounds to 0 to 1. X squared. And notice my b value is negative, so I won't put a plus bx. I'll actually put a minus 11 point, let's make sure we're in our pen, 11.949, because this 6 rounds up that 8, x. And then lastly, our c value is positive, so I'll put plus 17.75, and yeah, that 6 rounds up that 5 as well, 6. Alright, I now have modeled my quadratic regression, and I can now attempt to answer this problem. So before I kind of really clear this up, remember, we're looking for where y is equal to 260. So how am I going to write my equation? Well, in place of y, I'm going to start by writing 260. All right, let me pause and clear this up for you guys. Okay, so to finish this problem, what we're going to do is we're going to go ahead and we are going to solve this quadratic. So what are the steps to solving a quadratic? Well, first things first, we know we always want to set a quadratic equal to 0. Would it be easier to move one thing on the left side or 1, 2, 3 things on the right side? And in my personal opinion, it's easier to move 1. So the opposite of a positive 260 is a minus 260. And so I can go ahead and subtract this over here. So now we're going to have 0 is equal to 4.991 x squared minus 11.949x. And from here, we want to go ahead and grab our calculator. And we can go ahead and do 17.756 minus 260, which will give us negative 242.244. And notice at this point, we can now label our A term, B term, and C term. I know that this is my A term. I know that this right here is my B term. And of course, this right here will be my C term. And let's go ahead and continue on. We know we're going to use the quadratic formula. So we have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now notice, why are we using the quadratic formula? Well, because these are all decimals, it would be impossible for us to use any one of our factoring methods. And this is the benefit of using the quadratic formula. When you get comfortable with it, we use this for anything that involves decimals or difficult fractions. Okay, so let's go ahead and remember, my trick for y'all is to always leave parentheses in all the spaces all over 2a. And let's fill in everything that we know. We know that it always starts out with the negative b and b squared. So here I'll write in minus 11.949. And over here I'll write minus 11.949. I know that I then switch over to my A term, this nice little purple, and my A term is going to be 4.991. And down here, 4.991, because remember, A is right there and A is right there. And lastly, this C color, which I have in blue, will, and you know what? I need a little bit more space for that. This C color that I have in blue will be minus 242.244. And so we have that. All right, y'all. So let's go ahead and start working through this. And this will be kind of tricky, so let me clear things up for y'all. Okay, how in the world are we going to tackle this? Well, remember, we always use the same process to start. We'll start with what is on the outside, and a negative times a negative will be a positive 11.9949. Make that a better 4, I guess. All right, plus or minus the square root of, and here we have negative 11.949 squared. So guys, go ahead, grab your calculator. And remember, anything squared will always be positive, so 11.949 squared will give us 147.779. Now, what I like to do here is whenever I'm going through these 3 terms, is I actually like to count up my negatives at the start. I have 1, 2 negatives. A negative times a negative is a positive. And then this just allows me to multiply these numbers. I can do 4 times 4.991 times, and if you're following my method of counting up the negatives at the start, we just put in a positive 242.244. And we are going to get this number right here, 4,836.16. Okay. And then we're going to put all of this all over what is 2 what is 2 times 4.991? And this will give us 9.982. Alright guys, ask yourself, what do you think would be the easiest next step? Like, what would be the very easy next step? Well, what I would always encourage you to do here is then to begin to simplify what's inside our square root. So we can say x is equal to 11.949 plus or minus the square root of, if I take 147.779 and I go ahead and add 4,836.16, I'm going to get 4,983.94. And remember, this is all over 9.982. Ask yourself, what would be the next thing that you would do? Well, hopefully you're saying the square root. So we want to take the square root of that number. And then from here, I kind of like to do 2 steps myself. I like to do 11.949 plus, and I'll leave a nice little blank space here, over 9.982, and then comma, and then I'll also do 11.949 minus, I'll leave a little blank space there, 9.982. Okay, so let's go ahead and take the square root of this, and so I see that the square root of 4,983.94 is going to be 70.597. 70.597. So remember, in one case we are adding this value, and in the other case we are subtracting. So let's go ahead and write our second to last line, because here we now would like to add what is on the top. And so I can do 11.949 plus 70.597, and we're going to get 82.546 all over, and just back in this blue to show you didn't change, this 9.982, comma. And then guys, what about over here? Well, we're going to now subtract these two numbers. So 11.949 minus 70.597, and we're going to get negative 58.648 all over, and of course that bottom did not change, 9.982. Now, the very last thing we have to do is we have to divide those. So as you were writing all this down, let me just kind of erase everything up here at the top, and let's go ahead and finish this problem off. So we're going to say, okay, well, x is equal to, and if I do this very first one, 82.546 divided by 9.982, well, I'm going to get this, 8.27. In my final answer, guys, I like to round down to 2, comma, and our other value will be x is equal to negative 58 so we're coming from here, negative 58.648 divided by 9.982, and we'll get negative 5.875, but that 5 will round that 7 up to another 8. Alright, now your answer choices, depending on how you use your decimals, could be slightly different. So in this case, when you go look at the answer choices, you want to choose the answer choice that is relatively close to these two values. Okay, so let's take a look here. What answer choices are closest to these two values? Well, we can clearly see that the answer is going to be B. The answer is going to be B. Now I want y'all to notice something. What is really going on here? Well, we're saying that if here, as we go up the table, our x values are decreasing, here we would find negative 5.087 from the answer choices, but we found it's really 5.88 the way we used our rounding. And if we went over here and we were to continue this down to the more positive direction, and we were to write 8.27, these are the two spots where this quadratic is equal to 260. So in this case, there are actually two answers. So what's really going on there? Well, we're saying this. We're saying that we know our quadratic probably looks something like, honestly, yeah, it looks something like this. and that when we are at a x value of negative 5.88, and you were to go all the way up to where you would hit this quadratic, well, it's going to be at a height of 260. If we continue on over here, it's at a height of 260 when the other x value is going to be this 8.27. All right, and so that's really what's going on. And so we just took in this data and we have modeled a quadratic regression. All right, good luck.